Welcome to VC Physics with at VC Tutor today. We're exploring Newton's theories of motion, including his three laws, equations of motion, projectile motion, circular motion, and momentum. Let's get started. First, let's recall the equations of motion, also called SUVAT equations. These equations describe how objects move when they are accelerating. Newton's first law is the law of inertia. It says that an object will remain at rest or keep moving in a straight line at constant velocity unless acted upon by an external force. For example, a hockey stick puck sliding on ice keeps moving under friction or another force acts on it. Newton's second law is the most famous F is equal to ma. This tells us that the net force acting on an object equals its mass multiplied by its acceleration. This means a lighter object accelerates more quickly than a heavier object when the same force is applied. Newton's third law states when one body exerts a force on another, the other body exerts an equal and opposite force back. For example, when a balloon lets air out, the air rushes backwards, and then the balloon moves forward. Action-reaction forces always come in pairs. Next up is projectile motion. A projectile is any object launched into the air with no further contact with the ground. As it moves, gravity pulls it downwards, causing it to accelerate. When thrown upwards, an object slows down until it reaches its highest point, also called the apex, where velocity equals zero, then accelerates downwards again. The SUVAT equations can be applied here, with acceleration equal to g, which is 9.8 meters per second squared. Uniform circular motion is when an object moves in a circle at constant speed. Even though its speed doesn't change, its velocity does, because velocity depends on direction. The force that keeps it moving in a circle is the centripetal force, always pointing towards the center. Example includes hammer throw, roller coasters, or satellites orbiting Earth. Here we have a ball turned vertically upwards in the air. It decelerates until it reaches an apex, the highest point to be reached upwards. At apex, the ball is known to have zero velocity, so we have a bar here instead of a ball. It then accelerates downwards. Note that final velocity is equal to initial velocity with a symbol negative behind it, that is v is equal to minus u. Circular motion in a horizontal. Uniform circular motion. Speed is equal to distance over time or circumference over period. Circular motion is common throughout the universe. Now here we have known that with centripetal motion, force points towards the center. Given examples beneath. Period and frequency for circular motion in a horizontal plane. An object moves in a circular path of radius r meters with a constant speed of v and takes t seconds to complete a revolution. Time taken to move across a circle is called its period, capital T, of the motion. The number of rotations correspond to the frequency, f. We know speed is equal to distance over time. Here, speed is equal to circumference over period, where of course period is denoted by capital letter T. The velocity of hammer at any second is tangential to its path and changes continually. Even though it has constant speed, we have Hello Kitty here throwing the hammer. Since the velocity of an object traveling in horizontal circle is changing, it's accelerating, even if its speed remains unchanged. The inward vector experienced by an object moving in circular motion is called centripetal acceleration. Have a go at these questions. More questions to cement understanding. A simple yet effective illustration of Newton's laws of motion. Force, energy, mass, and their relationships between each other. Here on the rainbow, we have m1v1 plus m2u2 is equal to m1v1 plus m2v2. So this is essentially the momentum equation. Law of conservation of momentum. When objects move, collisions may occur. The Newton's cradle is an excellent example of collision. So momentum is equal to mass times velocity. Velocity is given in meters second inverse. Mass is given in kilograms. The SI unit is used here. Hence, momentum is expressed in kilogram meters second inverse. This is further about momentum and the equation of momentum and the conservation of momentum given here. Law of conservation of momentum, of course. Rainbow illustrating more on the right-hand side in the picture. And why is momentum a vector quantity? Read more to find out more. Conservation of momentum follows Newton's second and third law. Impulse is the change in momentum. It's equal to the force applied multiplied by the time of interaction. That's why cars are designed with crumple zones. Increasing collision time reduces the force experienced. For those curious, there's an illustration and a short yet sweet example of what it really means. Work is done when a force causes displacement in the direction of the force. Work is the way energy is transferred. For example, when you lift a ball, you're giving it gravitational potential energy because of its position in Earth's gravitational field. So, to recap, Newton's three laws explain how forces affect motion, SUV-AT equations help us calculate motion, and concepts like projectile motion, circular motion, and momentum tie everything together. Thanks for watching. Don't forget to like, subscribe, and check out at VC Tutor to You for more free VC Physics videos.